Hi everyone, very good evening to you all. So, welcome to this exclusive session on data science that we are doing for you guys only. So, unfortunately, there were some issues with the Zoom server today and the previous day. So, we are doing this exclusive session on YouTube as an unlisted session for you guys. And you might not be expecting me to come for today's session, but I'm Pradeep Bhaiya. I have joined Mohit to see all goes well here with the
Yeah,
session.
I am joining Mohit.
So it's good to see a lot of you are excited for today's session and coming here to learn something new. So Mohit Bhaiya will be teaching you how to um, work with Python and how to get started with basics of data science by building a small project that is going to be face detection using OpenCV as well. So Abhishek, thank you for the compliment. I think I am audible to everyone, right? Hi, Lakshay. Hi, Suraj. Right. So before we begin, if there are any questions around the session, you can ask me. Otherwise, I will just hand it over to Mohit Bhaiya. You can also post your doubts in comments, anything you do not understand. And this is you will also get a certificate at the end of the session for completing it, and I'm sure you would be able to build your first face detection project as well. Okay, so attend this session. We are just noting down all your attendance who all are coming, and we will also provide you with the certificate. Okay, so I'm handing it over to Mohit, who will be teaching you how to go with this session. Okay.
Hello guys, am I audible? Am I audible guys? Hello, hello. Hi. So so let's start with the session, right? I hope you can see my screen, right? So let's start with data science, right? So hello, my name is Mohit, and I'm mentor at Coding Blocks. So this session will be on data science, so basically introduction to data science, and we'll be doing one project which is face detection, right? So the agenda will be we'll see like introduction to machine learning and data science. So we'll see what is similarity between data science, machine learning, and what is the difference between machine learning and data science. And we'll see we'll cover some Python, right? We'll cover some Python basics first, and we'll directly then jump into face detection, right? So when we talk about machine learning, so machine learning it is basically the providing machines the ability to learn and improve from experiences. So for example, if you let's suppose there is a 2 month old kid, and if I ask that 2 month old kid to differentiate between cat and dog images, so he won't be able to do, right. But as soon as he grows, and let's suppose after 5 years, now if I ask him to differentiate between cat and dog images, he will be able to do very easily. So what actually happened in these last 5 years? So he actually learned what are the differences between cat and dog, right? So similar way, like the human learns, similar way machines also learn. So machines learn from their experiences. For human experiences can be any data, like the previous experience, the past experiences. But for machines, we have to provide that data in order for their learning, right? In order to learn any for making any computer learn. So that technique, so that ability for providing the machine so that they can learn and improve is you're actually machine learning. So there's a small example of machine learning. So let's suppose this is marks predictions. This example is of marks prediction, and the first column is basically the number of assignment you have submitted in your semester, assignment submitted. The second column is we can say number of hours studied. Let's suppose number of hours studied a night before an exam, right? And the third column is your bunk lecture. bunk lecture. And the right hand side of this equation is actually your marks. This is your marks, right? So can you find any relation that maps input, because these are your inputs and this is your output. So can you find any function or relation that maps input with output? So basically, I hope everyone knows what is function. So y is equal to fx. So can you find any function just looking at these observations or these examples? Guys, anyone? Can anyone find any function? So if you look carefully, you will see two in the first equation. Yeah, someone said it right. 2 into 4 minus 5, which is equal to 3, right? Because you do 2 into 4, which is 8, minus 5, it becomes 3. So what you did is assignment. You have taken the assignment column and you have multiplied assignment into your hour studied. And you did subtraction with bunk lectures. And it actually becomes your marks, right? So this is your marks. So if I ask you, how did you get this formula? So there is no specific answer that there is no algorithm that you get this formula, right? You just did hit and try. You just observe the pattern and you find out with you come up with this function. But actually, machine learning try to find this function using an algorithm. So that is the most important thing, that machine learning tries to find this function using an algorithm. So let's suppose you have got this function, right? Now, if I ask you, a student has submitted 3 assignments and has studied for 4 hours and he bunked 6 lectures. What CGPA or you can say marks he will get? Right? 3 is your assignment submitted, 4 is your hours studied, and 6 is bunk lectures. So what CGPA he will score? He will score 4 into 3 into 4 minus 6, which will be equal to 6, right? So you can see this data was not in your original data. So original there were 8 examples, but this data was not there, right? Still you are able to predict marks for this student. Let's suppose this is new student. Let's suppose this is new student. You're still able to predict marks for new student, right? So this is the beauty of machine learning, that even if there was no data, right, of this new student, you are still able to predict the marks. So the whole idea of machine learning or data science is to find this function. If you get this function, you will be able to predict. You will be able to predict marks or any variable. Let's suppose you want to do self-driven car. You again have to find this function and you will be able to do self-driving car, right? So the idea is you have your data, something like this. You have your data, and from the data you write an algorithm, right? And this is what machine learning algorithms are, right? This is your machine learning algorithm. And after this machine learning algorithm or this algorithm, you get a function, right? You get a function. And once you get a function, you can predict or input, you can input new data, right? New data, you can input a new data and you will get the prediction like this. Right? So therefore, what we try to do, we try to generalize this function, right? There can be a lot of other functions as well that are trying to fit the first example, maybe second example, maybe just one example. But this function that we got, assignment into number of hour studies minus bunk lecture, this function is generalized. It is for all the examples. I hope this is clear, right? Now there can be multiple, like there can be many example of machine learning. So one example is language generator, where you can generate the languages. For example, you must have seen the Google boards, right? The Google boards auto suggest, or you can say auto complete your words. So that also uses machine learning, which is the algorithm is popularly known as Markov chain. So it uses Markov chain to do that work. And then we can also do projects like emoji prediction, where given any sentence, for example, I want to have a pizza, right? And it automatically suggests that perfect emoji. You can see the pizza emojis suggested, right? And Snapchat uses this technique, right? Deep learning. Snapchat uses this project. So if you write something, it automatically suggests some emoticons or even some GIF as well. So one is your autonomous self-driven car, right? You must have heard about Uber, Tesla. So they use a self-driven car. So what do you think? What is the input to this self-driven car? So let's suppose you are creating a model with self-driven car, and you have to give any input to it. What input will you give? Any examples? So you can see there is a camera on the top of the car, right? On the hood of the car, there is a camera located. What does this camera actually mean, or what does this camera do? What are the possible inputs of a self-driven car? Destination, location, right? So distance. So basically, the input can be a video, right? Input can be a video that whatever happening in the front of the observe the environment, whatever happening in the front of this car, and based on this video, what it try different technique. For example, it tries to object detection. For example, if there is a car in the front of the this particular car, or maybe it try to find the traffic signal, right? It can try to find the traffic signal, whether this signal is red or green, or maybe it can try to find some pedestrian. Are the pedestrian crossing the road or the footpath, right? Or maybe turn left turn or right turn. So depending on all these things, right? Depending on all these inputs, what can be the possible output to this self-driven car? So the possible output can be your acceleration. What should be your speed, right? Your speed of the speed of the car. The possible outcome can be the steering angle, or it can be you can say whether it has to take left turn or right turn, right? So it can predict, or it can outcome different things. So not necessarily we are just taking example, and not going into the whole of what how self-driven car works, but there can be multiple input, many input, or many like multiple output as well, right? Then we know that machine learning and data science is everywhere. So these are some popular examples, like email filtering. You must have heard about spam email and non-spam email. You have to classify whether any email is a spam email or non-spam email, right? And then recommendation. You must have heard about recommendations, right? And there are like other lot of examples. But so there are two popular, you can say, subfields of machine learning. One is the computer vision, and one is your NLP. So what computer vision basically means? Vision basically means to be able to see, right? If anyone can see, he has a vision, right? Similar way, we want to give this vision, the ability to see, this ability to the computer, so that computer can also see. Now you can see this the image at the right hand side, right, where people can, where this computer can locate people, right? So what it is actually doing, it is able to locate people. It means it is able to see how many people are there, like how many persons are there, and they are walking similar way. The box is also changing. So this is the computer vision, where you work with images or videos, right? And the second subfield, popular subfield, is natural language processing. Natural language, you must have heard about like Google Home, Alexa, or Siri, right? Cortana. So all these models, or all these you can say all these machines works on your language. If you talk to Google Home in English, like turn on the radio, or maybe book a flight to Mumbai, right? So they understand what you are saying. So how they understand, actually, that is the whole natural language processing works, right? Voice messages can be considered in natural language processing. Now there are some popular library for machine learning or data science. So we have like NumPy, Pandas, OpenCV, Matplotlib, Scikit-learn, And then we have some deep learning libraries like TensorFlow, Keras, right? So we are not restricting to any specific library, but they can be like multiple lot of libraries you can use. When we talk about type of machine learning, there are generally three types of machine learning. One is supervised learning, unsupervised, and reinforcement. So in supervised learning, what actually happens while training the model, we have our input data, as in we have the input and both the output data, right? So for example, when you are doing the marks prediction in the last example that we have just solved, we had your input, we had labels as well, right? The output as well. So such type of learning is supervised, where we already have labels, right? And in unsupervised, we just have the input data. We do not have the labels. And in reinforcement generally talk about reinforcement learning is more into towards game, right? So let's suppose if there is a player who takes an action, any action maybe on the environment, and depending on that action, that agent, or you can say that character gets some reward or punishment. So if he gets some reward, if he takes good action, he will get some reward, right? He maximizes his reward. Same way. But the major part of the machine learning is supervised learning, and in supervised learning we have regression and classification. So classification is one of the most important, you can say, most important type of category that we can work on. So in classification, what actually happens is I'll give you some examples of classification. So one example of classification can be you have to you have to predict whether any person will have cancer or not, right? So see, what you have to predict whether a person will have cancer or not cancer, right? So you are trying to classify a person between cancer or not cancer. Another example, you have given any image. I give you one image, and given any image, what you have to do, you have to tell whether this image is a cat image, dog image, horse, or human, right? Out of these four categories, you have to classify any image into these four categories, right? Uh, Now let's take one more example. The spam email, right? You have given any email, you have to tell whether this email will be, or you can say classify this email as spam email or non-spam. So I hope the idea is getting clear that what we can do, we have to in classification we have to classify between classes, right? We have fixed number of classes and we have to classify between these classes. Now in regression generally output the real number. Real number can be anything. For example, if you take the stock price prediction, now stock price can be in real number as well. House price prediction, house price can be in real number. For example, $1,605, right? For example, marks prediction. Marks, you can have 6.7 CGPA, 7.2 CGPA, right? Real number. You can differentiate between now supervised regression and classification, right? So this is just one example. This is one example of regression. This is one example of regression where these are inputs, right? These are your inputs, and this is your output, right? These are your input, these are output. Now you can see this output can be in real number as well. So maybe you can predict something like this, right? But in classification, so this is classification. In classification, what we have to do, we have to classify between either this is zero class or cross class. This is binary because either it is this one or this one. Now this is multi-class because you have to classify between this one, and this one, right? Either it will be square or triangle or crosses, right? So I hope you are getting what is regression and classification, right? Uh, so now by now you must have like you got some idea of machine learning, how actually machine learning works, and it learn actually any hypothesis function. You can say a function which is a generalized function, and the algorithm that we write can be different, right? There can be multiple different algorithm for any purpose. So if we talk about what is machine learning and what is data science, so so there is a comparison chart, right? So you must have heard about AI term, right? You must have heard about AI term. So let's suppose this is AI, right? if we talk about AI is any model that is in production part. So basically, even if you write some manual rule, if you write AI, even if you write some set of rules, and you do it in a production level, it will become an AI, right? For example, self-driven car, or maybe a Snapchat type of filters. Inside AI, you have a topic, or you can say subfield of machine learning. Now, machine learning generally deal with statistical formula. For example, getting any formula from the data and having a generalized formula so that it can predict for next example, new examples, right? So, generally, basically, machine learning deals with the statistical formula, and there is a subfield called deep learning. Now, deep learning generally deals with deep learning generally deals with your neural networks. So you must have heard about that in human brains we have multiple neurons, like lot of neurons, billions of neurons, right? And these neurons are connected to each other, forming a neural network. So in human brain we have a biological neural network, and scientists have proven that like humans have the highest tendency to learn anything. Like they can learn, humans can learn very easily, like very fast. The same way, like the how a human brain works, we actually do not know, but the idea that human brains learn very fast, very you can say exponentially, the same idea we want to mimic on computers, right? Therefore they come up with something called ANN, which is artificial neural network. The same way we have biological neural network, the this way we have artificial neural networks, which is in a computer, right, in our machines. So deep learning deals with neural networks. Now, if you combine all these field things and some other things as well, it will become data science, right? So data science has AI part, machine learning part, data deep learning part, plus some other things as well. For example, you have to do scraping, like data acquisition from maybe you can do from API calling or maybe web scraping, right? And then you have to do pre-processing, right? So there can be other things as well. For example, you have to deploy from maybe like using some Flask framework, right? So we can have multiple things in data science as well. So apart from AI, machine learning, and deep learning, we can have multiple things, other multiple things as well, right? So this is the data science, right? So obviously, data science is a very huge field. It includes machine learning, deep learning, ML, and other things as well. But one thing that we are going to do is today is the face detection, and we'll use something called har cascade that we'll talk about it later, right? But before starting with face detection, let's first do some Python basics, right? Because it is important to do Python basics. So those who do not know Python basics, they need to know Python basics first, right? So those who already know Python, right? So what they can do, they can just quickly do whatever I'm doing in a code part. They can quickly revise that. Like for the half an hour, we will do Python basics, and then we will move on to face detection, right? I hope this is okay, because it is really important for everyone. Like for those who do not know Python basics, so they need to know Python, right? Otherwise, they won't be able to do the face detection. So I would say basically like you should have Jupyter Notebook first, right? So those who already have Jupyter Notebook, they can launch their Jupyter Notebook, right? They can launch their Jupyter Notebook. And those who do not have Jupyter Notebook, what they can do, they can search for Google Colab. Just search for Google Colab here. Just search for Google Colab, and you will get the first link. Open the link, open the link, and create a new notebook here. Like you can create a new notebook, and you will get the structure, right? The same way we are doing in Jupyter Notebook. So those who do not have Jupyter Notebook, they can work on Colab. Otherwise, those who have Jupyter Notebook, they should open their Jupyter Notebook. And I have created a directory or a folder at desktop, face detection. And let's go to this folder, page detection, and let's create new Python 3 notebook, right? Right. So let's write Python basics. So this is how you can rename your notebook, right? From here, you can rename your notebook. So let's write Python basics. So most of you like Python is very simple than other languages. So you will be able to know like what I'm trying to do. For example, if I write print and hello world like this, so you must yeah you must have known like what I'm trying to do. It is just basic printing hello world. Now comment in Python start with hash and to run this cell. So basically this is called cell. To run this cell, either you can click here run, or what you can do, you can also do uh, shift plus enter. So if you do shift plus enter, you will execute this cell. So you can see it has executed, right? Hello to data science, right? So these are the two ways that you can use to run your cell. So basically, I personally prefer using shift enter, right? Now, how do we create variables in Python? So basically, it is as simple as that. You create a is equal to 9 and variable has been created, right? So if you want to print any variable, you write print of a. Simple. Now let's check some control flow. Control flow. You must know about if else and loops, right? So let's do a is equal to 11. I'm creating a new variable a is equal to 11, and I'm checking if a is greater than 10, and instead of parentheses we have to put a colon, right? A colon, and here you can write greater than a is greater than 10, right? Otherwise else, and again instead of parentheses you have to put a colon and you have to write print a is smaller than 10. Now, since this is a if else condition, either this statement will execute or this statement will execute, and you can clearly see since a is 11, so this statement will execute and this will not execute. The second one will not execute, right? Now let's execute this shell, and you will see a is greater than 10. Obviously, as we expected, because a is 11, which is greater than 10. If you change a to maybe let's take 8, now you will see a is smaller than 10. If you want to create something like else if, you can write elif, right? In Python, we do not have else if, we have elif. So if you write a is less than 5, you can write a is smaller than 5. Otherwise, print no statement, right? So right now it is 8, and this statement is not executing because this is not fulfilling the condition. This is also not fulfilling, so it will come to no statement. I hope this is clear how we write if else conditions. Now let's talk about some like a basic while loop. For example, we have I is equal to 0, right? While statement, while I must be less than equal to 10. So this is the condition, right? We need a condition for while loop. This is the condition. We can do print I, and we have to increment it, right? So I plus plus does not work in Python. We have to write I plus equal to 1. And if we execute this, we will get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But one thing that I want to tell, that if let's suppose you want to print this whole 10 variables in a single line, what you can do, so by default there is a parameter in print function which is end, and it is by default /n. So what it says, after printing each word, just go to the next line, right? But what you can do, you can change this slash n to comma. Now you will see after each word printing, it print comma and then start continue, right? So I hope again this is clear that how we are doing this. Right? For the for loop, what you can do, let's suppose for I in range, you want to generate 10 elements, you can do this and do print I and end is equal to comma space like this, right? So range is a function that generates the value. For example, if you want values between 3 to 20, you can do this. It will generate values between 3 to 20. Right? So right now it is generating continuous value like 3, 4, 5, 6, 7, 8, 9, 10, right? But if you want to generate values in a gap of 2, for example, from 3 to directly go to 5, do not generate 4, right? So what you can do, you can write, oh, not here. You can write a third parameter, which is your step size. And step size, basically 2. So let's keep step size as 2. And you will see. So it generated 3 and 5 and 7, 9, 11, 13, right? So you can see you can directly print odd numbers. So without writing the if else condition, you can print the odd numbers this way, right? And a basic function that you can write. So how do we create a basic functions? The basic functions, it start with def, your function name, and it takes some parameter if required. Otherwise, you can skip that. And again, then colon, because we don't have to put parentheses in Python, right? We just put a colon and we write whatever you want to write. Let's suppose hello from function like this. And if you want to return something, just write return whatever you want to return. Otherwise, skip this part. You can skip, totally skip, right? So how to call this function? You call function name. You write function name and then parentheses this way, right? So it says hello from Python. If you want to pass some parameters, let's suppose you want to pass 3 parameters. Sorry, 2 parameters, 3 and 5. Let's accept 2 parameters A and B. And let's return A plus B, right? So we will get 8 also, because this function is returning A plus B. Right? So this is how we can create Python functions. Now let's come to some data structures in Python. Right? So we have very popular data structures. So data structures in Python. So we have some data structures like we have list, right? We have tuples, we have sets, we have dictionaries. Right? We have like these data structures in Python. Okay? So I hope everyone know about list, right? So list is very popular data structure that we use most of the time. List and dictionary. So these two are like my favorite data structures that I use in every project. In fact, like yeah, every project I have to use list and dictionaries. So list is you must have heard about arrays in C++ or Java. Like if you're coming from C++ or Java, you must have heard about arrays, right? So array can store a homogeneous type of elements, right? For example, if you can create array of integer, you can store all integer values. So list is very similar to array in Python or Java, in Python or C++, but it is more flexible. It can store heterogeneous elements. For example, you can store integers, float. You can store boolean value. You can store a list which is inside a list. So nested list. So I'll give you one example. For example, you can have values like this, right? You can have values like this. If you print L, so you get the whole list. So this everyone knows, right? You get the whole list. If you print L of 0, you will get first element. If you print L of 2, you will get second element. But what if you want to print the last element? If you want to print the last element 10, what you have to do is something like this: length of L, which will give 7, and minus 1, which will give 6. So whatever the element is at the sixth index, you have to access that something like this: a of 6. Right? Now you got the 10. There is another way to access the last element, that is L of minus 1. So let's comment this out. So let's comment this one, and let's write L of minus 1. Right? So what it will do, it will access the 10. So why it is accessing 10? So let's check why it is accessing 10. So there are two ways of accessing. So there are two ways of accessing elements in Python. So basically, indexing in Python works in two ways. One is your forward indexing, which is start with 0, 1, 2, 3, 4, 5, 6, right? So this is indexing that we are familiar with. There's another type of indexing in Python, which is called negative indexing or reverse indexing. Reverse indexing, and it starts with minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and minus 7, right? So if you want to access the last element, either you use 6 index or minus 1. If you want to use the second last element, either you use the fifth index or minus 2. So generally, if you want to access some last elements, negative indexing helps a lot, right? So this is just the basic of how you can access negative indexing, right? So there is a very popular technique called list slicing. So after knowing about the how you can do the indexing, there is a popular technique called list slicing, which is very popular. And what list slicing tells is, let's suppose if you want to take elements in between. For example, you want to take elements between 7, 8. Let's say these four elements. You want to create a sub list which will have these four elements, right? So basically, you want to extract these four elements from your list, not just the one element. If you write L of 0, you get 4, but you want these four elements. So what we can do is using list slicing, right? We will use list slicing. Now the syntax of list slicing is, you write L, which is your list name, and you put a colon. So here it comes the start index, and at the end it is end index plus 1. So this is the syntax. So if you want to take elements from 7 to 1, what you have to put, this is 0, 1, 2, 3, 4. What is the start index? Start index is SI is 1. And what is the end index? End index is 4, right? So what we have to put here is L of start index, which is 1, and colon end index, which is 4, plus 1 as well. Because if you do not write plus 1, the second part is exclusive. It always exclude that element. See this. It has excluded that element, right? The element 1. But if you write 5, it will access that element as well. So always remember that end index plus 1, right? So we have to put end index plus 1. So this is how we can do list slicing. So again, basically what a list slicing means, you have to put constraint between start index and end index. For example, if I do not put any constraint, so this is empty right now, this is empty, and this is also empty. What it will do, it will extract all the element from the list. Why? Because there is no constraint on the list. There is no constraint on start index, there is no constraint on end index. So it will take all the elements. So let's try to execute it, and you can see it has extracted all the elements, right? Because you have not put it any constraint on start index, end index. Let's put any constraint on end index. For example, let's put 6, right? Now you will see there will be only 5. There will be total 6 elements, and this 6 will be at the 6th index here, right? So it extracts these 6 elements starting. So you can like play with around, like you can change start index, end index. So you can do something like this as well. Again, it will execute the same thing, because take, it means take all element except the last one. So what it is actually saying, right? So you can do like a lot of things with list slicing. The same way we have list slicing, the we can also do string slicing. Like this is my string. If I write something like this, and if I do s of 0, I will get first element. If I do s of 1, second, right? S of minus 1, I get the last element, right? If I do s of from 3, or let's take from 2 to 12, I will get the sublist, right? Or you can say substring. So the same way, the how list slicing works, the same way we have string slicing as well, right? So someone said L of minus 1 colon minus 3. Why this does not work? Because start index is your minus 1, right? You're saying start index is your minus 1 and end index is your minus 3. So let's try to check what is your start index. So this is your start index, right? So from here, you have to go till, obviously you can go from front. You can go in front, but you are saying that you have to go till here. So this is your start, this is your end. Obviously, you cannot come back. You can do something like this, L of minus 3 and go till minus 1, because you can go in the front direction. If you want to go in the backward direction, there is one more property here, or you can say one more indexing. Just do the step size. So step size, you can put minus 1. But like not going to that detail right now. Now you can see it is going backward, right? So this is just actually step size. Either by default step size is 1. You can also put 2 or 3. So it will take 2 jump, 3 jump, or minus 1. But not going to that detail right now. So it prints the list in reverse order, right? So this is some basics of list, and obviously it acts like a list. So it has a lot of functions. For example, if you do l dot append, and you pass a number, right? Like 900. So what this append does, obviously, like everyone knows, it takes the number and add it in the last, at the end of the list, at the last, right? So if you check L, you can see 90 is there. But suppose you write L dot sort, you get the sorted list. Very easy, right? So we have like a lot of functions, right? Right now, I'm not going into details of these functions, or like you if you face any difficulty, just check what function is available, and you will be able to get that function. So that's why we say that we generally say that Python is not very difficult to learn, because it has just the functions, right? You don't actually have to implement the quick sort. Now we have done this list. There is thing called tuple as well. There is another data structure called tuple, and tuple is actually like a list. So I give you one example. So this is your tuple T. We do list like this thing, 7672, something like 682, right? We create list like this, but we create tuple like parentheses. We create tuples with parentheses bracket, right? So if you check T, so you can clearly see that this is tuple. You can clearly see that this part is list. List always start and end with square bracket. Tuple always start and end with parentheses, right? Now the only difference between list and tuple is tuples are immutable. It means you cannot change the value of tuple. For example, if you try to change the value of 0th element, lists are mutable and tuples are immutable. If you try to change the t of 0 as, maybe let's try to change it with 90, you will see it says tuple has no tuple object does not support item assignment, right? So you cannot change value of tuples, and rest other things are very same, right? It's just we cannot change tuple values. If you want to perform the slicing on tuple, you can do the same thing, but the only difference is tuples are immutable. And now let's quickly look at dictionaries. So dictionary basically means uh, hash map in Java, right? So if you are heard about hash map or hash tables, so the same thing we have. So same thing we have in a Python known as dictionary. So dictionary we can create dictionary like something. So let's create a canteen menu, and in canteen menu you have samosa for a price of, maybe you have samosa for a price of 10 rupees, 10 rupees, and then you have maybe juice with 20 rupees, and you have burger with a price of 30 rupees, right? So this is what actually happened. You have to put equal to, right? So this is actually what a dictionary look like, right? So if you want to print the dictionary, just write canteen menu, and you will see the whole dictionary. But the idea of dictionary is you can access these values. So you can see these value 10, 20, and 30. The idea of dictionary is you can access these value very quickly using these keys. Now you don't have to put this thing canteen menu of 0, canteen menu of 0, or canteen menu of 1, canteen menu of 2, because this is not indexable. Indexable basically means like we in the case of list and tuples, we used 0, 1, 2, 3, 4 to get the values, but dictionaries are not indexable, right? So we have to get the value using keys. So if you write canteen menu of samosa, you will get the price of 10. If you write canteen menu of juice, you will get 20 value, right? And if you want to check how many or total elements that are present or total keys that are present, you can write canteen menu dot keys. Right? So you got all the keys: samosa, juice, and burger. So these keys are present, right? One more example: if you try to do canteen menu of pizza, which is not present, right? Pizza is not present in our canteen menu. So it will throw an error. That error is key error, that this key is not present. But to avoid this thing, to avoid this error, what we can do, we can use a function called get. So we can say it is anti.menu.get, and if we pass now pizza, it will say pizza is not there, but it will not throw any error. Now you can see we did get any error. Obviously, we will not get any output, but at least we didn't get any error. So what we can do, we can do some you can say if else condition, right? If canteen menu dot get pizza is none, so just print pizza is not present. Pizza is not present. Otherwise, print canteen menu of otherwise print canteen menu of pizza. So now it will say pizza is not present, right? So I hope by now you must have known some basic Python. So it is not very, as you can see that it is not very difficult to understand what actually how Python actually works, right? So let me do just one thing. I'll push this code to the GitHub so that you can access this code, right? I'll push this code to GitHub. Just give me a. So if you want to access the code, just go to this link cv.lk/face work. Just go to this link cb.lk/facework. So let's try this link if whether this is working or not. cb.lk/facework. Yeah, this is working. So this is the notebook that we have just worked on, Python basics. So I'm giving you 2 to 3 minutes. Just go through this notebook, and if you face any doubt or if you are trying Python on your system, so just try the Python. Or if you face any doubt, just let me know in the chat, and then we'll move to the next thing. So guys, I think we should continue now. Right. So guys, let's continue now, right? So now what we can do, so obviously like you all are excited for face detection part, but before face detection, what we can do, we can quickly go through some libraries of Python. For example, there can be like multiple. So why do we use libraries, right? Libraries are generally used to make our work easier. For example, there can be functions that are very complex to make. Like if you do functions, if you write functions from very basics, they will be like very difficult to work with, right? You will face a lot of difficult time to write all these functions. So therefore we write libraries. We use libraries, right? We use libraries to make our work easier. So we have libraries like NumPy, Matplotlib, and OpenCV. So we'll see these two libraries very quickly. Yeah, we will use inbuilt functions. So most of the inbuilt function we'll use. So let's talk about NumPy first. So NumPy is very important. You can say very important libraries, because when you work with images, images are nothing but just numbers, right? Images are arrays or three-dimensional numbers. So you will see right now, when we work with images, you will see these are just the numbers, and you will be very easily able to work with images if you just understand NumPy. So when you have to work with NumPy, first you have to install that package. So we can install this package by writing pip install NumPy. So those who are working in Google Colab, they do not need to write pip install NumPy, because it is already installed. It is already installed on their Google Colab. But those who are working with their local system in their maybe Jupyter Notebook or any other IDE, they can write pip install NumPy. Right? Once you write pip install NumPy, now you can see the requirement already satisfied. It means it is already installed. NumPy is already installed, right? And what you can do now is you can work with NumPy. So let's import NumPy as NP. NP is just a name for NumPy. Now we can create some NumPy array. Let's write a function np.array, and let's create a maybe a array like this. So this is an array A. Now this array, if you print just array A, right? This is a NumPy array. First of all, it is NumPy array because it is created from NumPy, right? It is created for. So also there is a type function in NumPy. So if you write type of A, you will get it is numpy.nd array, right? So so this A has some elements. So there is a property called A dot shape. So this is a property called A dot shape. If you run this, you will see 4 comma. It tells how many elements are there, and you can see clearly there are 4 elements. So you get 4 comma, right? I hope dot shape property is clear. What dot shape property does? So it tells how many elements are there. You can clearly see 4. Now let's create a 2D NumPy array, right? This was just one dimensional. You can see, you can also call it as a vector, right? You can also call it as a vector. Let's create 2-dimensional array. I call it A2, and I can create 2-dimensional array like this. So there will be one list, and inside this list there will be another list which will have 3, 5, 7, 8, and something like this, 4, 2, 1. Now I hope it is like it seems very clear that this is a two-dimensional array, like we used to have in our C++ and Java, right? If you execute it and print A2, you will see, oh, this look like exactly a two-dimensional array. And how many rows are there? There are two rows, and columns is, and how many columns are there? There are three columns, right? Why comma? Because this is the idea of creating, this is the first element, this is the second element. In one dimensional or just a vector, the element was just a number, right? Element was just a number. This was a number, single number. But right now we have elements as the whole list. The first row is whole list, right? Columns are three, right? If you print just A2, you get this. If you print A2 dot shape, what is the shape you expect? Can anyone tell what is the shape that we expect? So just take the reference from here. It gives how many elements are there. But if you take L2 A2 dot shape, what shape we expect? So someone's saying 6, someone is saying 2 comma 3. So actually the result is 2 comma 3. So it actually gives you the number of rows and then the number of columns, right? I hope now it is getting clear, like how this shape properties works. So it gives number of rows and number of columns. So we have number of 2 rows and columns were 3, right? So this was two-dimensional. So this was two-dimensional, right? And we have already seen one dimension. Can we create three-dimensional vector or three-dimensional array? Yes, we can do that. So not want to, like I do not want to confuse you right at this moment, but just for a fun part, I'm telling you this thing. Just don't get confused. If you print A3 and now A3 dot shape, it is actually a three-dimensional, you can see. So obviously, like it will be very, very difficult to visualize this matrix. So it will be something like this, right? And we have elements here at like 1, 3, 4, 1, 5, something. So don't want to like I don't want to confuse you, but we can have multi-dimensional arrays as well, right? So the idea is just I want to show you that we can have multiple dimension array. So we have like 3D, we can have 100-dimensional array as well, 100-dimensional. So we will at that point we will have how many first you can say how many rows are there and then how many columns are there. The first how many elements are in the second index, how many elements are in the third index, and same way till 100 dimension, right? So this one represents how many elements are in the first dimension. This represents how many elements are in the second dimension. This represents how many elements are in the third dimension. Here we do not say rows column because rows column are only restricted for matrix when we have two dimensions, right? If you are confused what dimension this array is, you can directly say a3 dot n dimension and it will give you this is 3 dimension, right? If you ask what is a2 dimension, n dimension, it will say it has 2 dimensions. I hope this is easy, clear. So images are nothing but just three-dimensional array. So we will see how and how we will see that how images are numpy array and how we can create any image from numpy arrays. So this was like basic of numpy, and let's suppose if you want to create a random number, right? So if you want to create a random number, what you can do, there is a module called np.random.randint, and this function randint basically it says it will create a random integer, right? It will take the low value it will take low value basically from what range. So I'm saying from between 1 to 100 high range, create a random integer like this. It has created 65. Again, if you execute it, you get 51. Like you might have you can get a different number as well, right? So every time you are getting different numbers. But what we can do, we can generate the whole matrix from random number. For example, there is one more parameter called size. If I say 5 comma 5, so you oh, we get some error. It should be size equal to 5 comma 5. So we got the 5 cross 5 random integer, right? You can clearly see. So instead of getting one integer, I'm getting 5 cross 5 random integer. So now you don't have to create any metrics for, you can say, like for your experiments, right? So let's call this as a rand matrix, right? Random matrix. If you print random matrix, this is a random matrix. Now, very easy, right? The first question is very easy. If you want to access the first element, how would you do that? How do you access the first element in a matrix? Anyone knows? How do we access first element in matrix? 0, 0, right? Simran said 0, 0. So if we write 0, 0, we will get 26. That was our first element. If you want to access the last element, what would you write for the last element? For the last element, for 56, this one. We can write -1, right? -1 and comma -1. So I hope this is clear that if you want to access any one, and yeah, 4 comma 5, 4, we can also write 4 comma 4. That would not be very difficult to write. But if you got the point, right? If you want to access any element, maybe any element, let's suppose this, it has a row number of 2, index of 2. Row is 3, but index is 2, right? And column has 1, 2, 3, 4, it will be 3. If you write 2 comma 3, you get 68. But let's suppose if you want to get these 6 elements. Now we talked about list slicing in Python. Same way we have array slicing in NumPy. Array slicing basically means you can take the continuous rows or continuous values, subarray of continuous rows and continuous value, right? So what we are going to see now, array slicing. Same way we have the way we have list slicing, we have array slicing, and the syntax is your array. How many rows are there? How many rows you want to select, and comma how many columns you want to select. This is the syntax. So I'll give you one example, right? I'll give you one example. For example, if you want to access these highlighted elements, you will say random matrix column. How many columns are there? So basically, which columns are there? So this is column number 0, column number 1, column number 2, 3, 4. How many columns I want from here till here, right? So can I write this? So I want from column number 2. Sorry, why is I'm saying column? It should be row number 2. You can see row number 2, which has an index of 2, till row number 4 plus 1. Because this was the last column. If you write just 4, you will get up to this point. But you want 4 plus 1. So you will write 2 colon 5 in the rows, right? In rows, you will write 2 colon 5. And in column in rows, right? In columns, you will write 0, 1, 2, 3, 4. You will write 1 colon. In the column, you will write 1 colon 4. You will write 1 colon 4. Right? So if you execute this, now you can clearly see you got the same result. Right? What you wanted. This thing. right? So I hope this is clear. Just based on indexing, you can do, you can take any you can say sub array. Now I want you to write a line of code that can take that can take uh, these elements. So what we have to write for these elements? So random matrix, what column, sorry, what rows should be there and column should be there. It is comma and column should be there. So just write for these things. So I got the answer right, correct. Someone said random matrix of 2:4, comma 0:5, and you got the same thing. See, 79, 18, 99, 68, and you get the same thing, right? Or you can skip this colon as well, or zero is as well. So if you write zero somewhere, you can skip that as well. Still, you will get the same thing, right? Or you can write -1 here. So you can see like there are different techniques of writing the same thing, because it is up to you what how you want to write the indexes, right? So this was just the array slicing, right? So we are gonna see one interesting thing that you'll just see in a minute. I hope array slicing is clear to everyone, right? So you will see you will actually crop your image using the array slicing. So like NumPy is a very huge library. We are not going to very detail of NumPy. So if you want to do anything in NumPy, just write np dot, and there are a lot of functions available with NumPy. So just press tab and you'll see there are a lot of functions. So for example, if you want to take the absolute value, ABS, for example, what is ABS of -5? It is 5. So we have like lot of functions in NumPy. For example, if you want to take the sign value, right? Sign value of 0 is 0. There are a lot of functions. There are a lot of functions available with NumPy. So obviously, I cannot go through all the functions, but I'm just going through like important functions that we need for face detection, or some like small mini project of face. You can say image cropping or collage generation, something like that, right? So if you want to check the functions, you can just write np dot, and you can see there are like a lot of functions, right? So what I'm going to do right now is there's one more package called matplotlib. I'm just using, I want to read an image from my current directory. For let's example, okay, let's take one example. So you can see this is an image of Meowth. So right now I have the image of Meowth in the same folder, right? Because we have NumPy here in the folder. I have image of Meowth as well. Now what I will do, I will read this image. I will read this image in my work directory. So, so for this purpose, I need another library that can read images. So I'm using matplotlib, right? So since it is again a new library, what you have to do, install pip install matplotlib, something like this, right? You can install pip install matplotlib. Just do execute it, and it says requirement already satisfied because it is installed. It will make it might take like 30 to 50 seconds to install in your computer, but once you do this, it will be installed. and you can do import matplotlib.pyplot as plt. Just do this thing. Why I'm doing this? It might look like very crazy at the at the beginning that I'm taking like help of lot of packages. I'm importing something like this and something like that. But it's just I want to read any image because you do not know the code of reading images. You might know some file handling, right? You know some file handling. I'm pretty sure that you must have done file handling like reading image, reading files, writing files, or all these things. But that can be like very tricky if you read binary files because image is a binary file, right? So therefore, I'm just using PLT or matplotlib, this package, to read directly an image. Right? So what I will do right now is there's a function plt.imread, right? plt.imread, and I will give the path of the image. For example, right now I can check out which path I am in. So what are the you can say ls is command on Unix, right? Linux. So ls basically tells what all files are there. So you can say in my current directory, one file is numpy.ipython notebook. This one is your Python basic IPython. This one is your README, and one is meow.jpg. So I can directly write something like this: dot slash and meow.jpg, like right. So those who are using Google Colab, just go to the left hand side of your screen, and there will be option to upload an image. So maybe if I can Colab, or I can do. So just go on Google Colab, and on the left hand side, you will see there's an option to upload any image, and you can use that option to upload images. So just go this point, and so you will see any upload button here at this point. Just go to this point, and you will upload the file, right? So now if I execute this cell, and it is executed, right? So what this image variable is. So this image variable, if you check the type of image, so type is a function of Python. Type is a function of Python that can tell the data, the type of data type of any variable. For example, I pass a list. Let's suppose this is a list 1, 2, 3, 4, and I ask what is the type of L. It will say this is a list. I will ask what is the type of false. False is a boolean. Everyone know, right? Boolean. So similar way, if I ask what is the type of img, it will say numpy.ndarray. Now most of you have already seen when we get numpy.ndarray, when we have something like this, right? Or something like this, or something like three-dimensional, right? So it means images are also numpy array in our computer. So it means I can print it. So yes, I can print it. Now you can see these are all numbers, and these numbers are between 0 to 255. These numbers are between 0 to 255. 0 means complete black. 255 means complete dark. Oh, complete bright. It means white color complete. It means complete dark. So these are basically the pixel intensity at any location. And if you ask what is the shape of it, it says 250, 250, 3. It means it has 250 rows, 250 number of rows, right? 250 number of columns, and we have 3. This is your channel. Have you ever heard about RGB? So this is what actually RGB is. So basically RGB means red, green, blue, right? And this is what actually RGB is. RGB basically means 3 channel. So similar to this, we have red channel, we have one more channel which is your green channel, we have one more channel which is your blue channel. So therefore this matrix is 250 250 cross 250. Middle matrix is also 250 cross 250. The third matrix is also 250 cross 250. And combining all these three matrices, it will become 250, comma 250, comma 3. Right? So basically 250, this means height of the row, basically means height of the image. Column basically means the width of the image. And 3 means it is RGB, colored image. Now we have got the image, but we can't visualize it, right? So for visualizing, let's do one more function, which is plt.imshow. So imread is for reading images, imshow is for displaying images. So let's do plt.imshow and img. Now you can see this is actually the image of a Meowth, right? That we actually displayed in the directory. See the same image, right? So I hope now you are getting why I said that images are also just the numpy array. So if you just do plt.imshow and image, and if you compare it with image img variable, you will see the similarity that image img is just a variable, a numpy array. That actually the image img just stores the pixel intensity of each pixel at that point. So for example, if this is a numpy array, img is a numpy array, can I do array slicing in this? So the question is, if an image is a numpy array, it was 3-dimensional numpy array, right? So can I do array slicing? For example, if I want to extract this part of the matrix, or you can say array, so can I do this? So let's try to do this thing, right? So it would be very easy. Let's try to extract the face of Meowth. For example, how we can do this? We have image, and right now we do not have two channels. Right now we do not have 2D metrics, right? The numpy array we have is 3D. So first, it will be number of rows. How many rows do you want? Second, it will be number of columns do you want? Third, it will be number of channels do you want? Channel basically represent RGB, basically red color, blue color, and green color, right? Now, how many rows do you want? So if you clearly see, so it is somewhere from this point to this point, right? And if I take a rough guess, it is around 120. This point is around 120, and this point is around maybe 180. Let's take 120 to 180 for rows. So 120 to 180. I'm taking very approximation, right? And for the column, let's take around 60 to maybe we can take 170, right? Or 70 to 170. And how many number of channels do you want? Do you want red color, blue color, or green color? Or do you want all these three colors, RGB color image? We want all these three colors, right? We want all these three colors. So what we can do, we can just put a colon. Colon basically means you do not want any start index and end index. Just put the colon, right? There's no constraint on row on the index. Or you can just write 0 to 4. The same thing. Both are the same thing. Just put a colon or this thing. Now I will say, see, you got a sliced array. So this array is a sub-array of the whole image. I will say it Meowth. I will say it Meowth face, and now plt.imshow Meowth face. I will do this thing. So now you can see you got the Meowth face, right? You have actually sliced or cropped your image to the Meowth face. So can we have more than 3 channels? So Manik, we cannot have more than 3 channels. Either you can plot one channel, which is your black and white grayscale images, or you can plot 3 channels. You can have more. You cannot have more than 3 channels. Basically, like we can also have one thing is called alpha, or you can say RGBA, which is your alpha channel. It basically means sometimes if you see the PNG image, PNG in what happened actually in PNG image is sometimes we get background color and sometimes we do not get background, right? So that factor is your alpha, but like we can have more than three, right? The fourth part is your basically the channels or the alpha. So why I haven't mentioned the channels? So basically because I do not want to slice or crop the channels. I want to take all the channels. That's why I just put colon. If you want any specific channel, you can write I want zeroth channel, I want first channel, I want second channel, right? Because I want all the channels, that's why I put colon. Right. So this is how easy to crop any image in using the Python. And what I would say, so let's do very interesting thing. So let's suppose there's a matrix called 5 comma 2. There's another matrix, we have 5 comma 2. So this is matrix A, this is matrix B. Now what I can do, we can stack them together horizontally, and it will become, the result will become 5 comma 4. Why 5 comma 4? The first part will come at this position and the second part will come at this position, and it will become 5 comma 4. So this is your H stack operation. H stack basically means horizontal stacking. So what you can do, take any image of maybe 100 comma 100 comma 3. So let's suppose this is your image 1. Let's suppose this is your image 2, 100 comma 100 comma 3. This is your image 2, right? Now you can stack both the images, image A and image B, with horizontal stack, and you can combine 100 comma 100 comma 4. No, it would be 6. So it would be 3 only. But what I'm saying is just put the first image on this part and put the second image on this part, right? Guys, are you getting? Basically, I want to create a collage where I just have to put two images, image 1 at this point, image 2 at this point. So I can read image number 1 with 100 comma 100 comma 3, and I can read image number 2 with 100 comma 100 comma 3, and I can do np dot h stack image A and B, right? So it will create a new image with stacked both the images. So you can also combine horizontally and vertically as well. So maybe C and D, something like this. So you can create in a filter, you can say collage like effect, right? So you can create a collage like effect, but that would be your assignment, your part to do. So just we have to think at stack, with stack horizontally like this. There is 1, there is 2, it will horizontally stack. We have V stack, you can vertically stack. If there is A, there is B, you can vertically stack them, right? So that would be your part, you have to do that thing, right? So uh, so now let's quickly jump to the face detection. So I guess this was enough for the library part. Not going to very detail, because like we have limited time and libraries are infinite. You cannot complete libraries like the whole library, because like there are a lot of functions. Guys, I have pushed the code. If you just check the code to the same link, cb.lk/, what was the link? Facework. So this was the link. If you check the code, if you want to check the code, you can see you have now numpy.ipython. So while extracting file, I am getting file not found error. So file not found error occurs when you do not have, actually you do not have file, or you do not have file at the right, you can say right directory. You are giving some, it would be a directory issue. So just check your code. If you what you want to see from the NumPy, you can do this. If you want to do like the cropping of images, you can try that, and then we'll quickly jump to the face detection. Nikhil, then it is not like possible that if the file is present at the right directory and you're writing the right code, then the Python code is saying that I won't execute it. I will give the error. So it does not happen. So might be like you are doing some error. That's why like error is coming. Otherwise, this is not possible, right? The link is cb.lk/face word. Just check the link, and then let's quickly move to face detection. I'm creating a new notebook. This notebook will be named as face detection. Right? And for face detection, we will be using OpenCV. Let's write this way: OpenCV. Right? So again, one more package. Some of you might think like, why do we use so much packages in Python? But this is it. We have to use like a lot of packages, a lot of function from different packages to make our life easier. Like we cannot write all these codes from ourselves, so we use packages. Again, one more packages. What we have to do: pip install OpenCV hyphen Python. Because OpenCV is also available for C++. Therefore, what we are doing is we are installing pip install OpenCV Python. So the Python version of OpenCV, right? We don't have to install the C++, just the Python version. If the arrays are not the same dimension, will it work? Obviously not. It will not work because you cannot stack. You cannot stack 5,2 with 10,2. You cannot do this. For this, let's suppose this image is 250, 250 dimension, right? And this image is 100, 100 dimension. So what you can do, you can resize this image. You can resize this image into 100, 100. Now, how to resize this? That would be your part to search for. So basically, we have a function called cv2.resize that we are just going to see. cv.resize, and just give this image path, this b path, and what size you want to convert, 100, 100. So it will resize. It will shrink your image to 100, 100, and then now both are suitable, or their shapes are matched now, and you will be able to h stack or v stack, whatever you want to do, right? So does plt.im read? So this function basically reads images from, you can say, disk. If you want to create images from numpy array, you don't have to write plt.im read. Just create a random matrix of 100, 100, 3, and just do plt dot. So something like this. Let's import NumPy. Let's import matplotlib, matplotlib.pyplot as PLT, and let's create 100 cross 100 image. So I'm creating np.random. Now I will just for now random and 100 comma 100 comma 3, something like this. Image dot shape would be 100 comma 100 comma 3. So if you do plt dot im show this image, you will get distorted image. You can see this is just a random image, and you never used plt.imread. Imread is just used for reading image from directory, or you can say the storage disk, right? But this does, we do not require this because this is a random image, and what we will do with the random image. So let's install Python, OpenCV, right? OpenCV. Let's install OpenCV. So if you execute this, it will be installed in maybe like 20 to 30 seconds. Right now it is already installed. Therefore, it's a requirement already satisfied. And for importing OpenCV, we write import CV2. Right? So this is the basically we can say that see this is second version of CV, right? Which is more stable. Therefore, we use OpenCV2 as copy. Now this has again lot of functions. Like there are a lot of different functions. The one thing that we are going to use is har cascade. So for right now, what I will do, let's take any group image. Can we take any group image, group photo? So let's take any group photo so that we can do the face detection, right? Let's take this photo and let's save it to desktop, the same folder with the name of group photo, group photo, right? You can also take your own photos or maybe any photo from internet for now. So this is the group photo, right? So we are going to do face detection on this photo. So the first idea would be to just read this image, because this image is in right now in the disk, right? This image is in disk. So what we have to do, plt.im read. And what is the name of this image? It is group photo.jpg. Let's call it image. And if you want to display the image, you can write plt.im show image. So this is our photo that we want to do face detection on, right? If you check plt.shape, it says 563 rows, or height is 563 and width is 1000 and number of channel is 3 because it is RGB image. So we don't have to install all the libraries in like every time. For example, like I have already installed NumPy and Matplotlib. Therefore, I didn't install NumPy and Matplotlib this time. Once you just install NumPy, Matplotlib, OpenCV, you will never have to again do the same thing. Just install the libraries once, and it will be able to work on all the files, right? If you do new Python notebook, you will be able to directly import all these modules. Now we have to do phase direction on this, right? So what we can do, just go to this link, cv.lk slash face model. Just go to this link and you will see a file like this. So okay, just go. Let's go to this link, cv.lk slash face model. So this is the file that we have. So this file is har cascade frontal face alt.xml, right? So this is the file that we have. We have to download this file. So let's download this file. Let's do direct download, right? And let's copy this file to that same directory. Let's copy this file to here, right? So let's copy this file to here. In the same directory, we should have all our files in the same directory. Now, why do we use this har cascade frontal face alt? So what does this file actually contain? So this file actually contains, in a nutshell, I can say this file know how a general face look like. For example, a general in like any face will have two eyes, one nose, and mouth, right? And similarly, we will have two ears. So this file will know how a general face look like, and we will take the help of this file to detect all the faces in our group photo. So, like I know that you won't be able to understand what it actually written, like leave rental or leave not. Even I don't understand what is written, but it's just the idea is it can understand faces in any given photo, right? So this is the idea. So now after downloading this file, what you can do, you have to use cv dot like a pre-trained model. Amit very well said, like a pre-trained model. This har cascade is already a pre-trained model that was trained by OpenCV guys, and they used like 100,000 images of different faces, maybe from India, Africa, US, like from all around the world. They use different faces, and they come up with this new file, har cascade frontal face detector, right? So now it is able to detect any face, but the condition is the face should be frontal face, basically front facing. If you face to the left side or right side, then this file will not be able to detect that. It is only frontal face detector. Now we have already downloaded this file. What we have to do is load this file on our memory, or you can say the workspace. This is our workspace. We have to load our file to this our workspace. So we can do this by using a function called cv2 dot cascade classifier. So this is the function name, and I will suggest that never write this cascade classifier on your like the full cascade classifier on your own. Just write cv2 dot cas. C is capital right now here. C is capital, and press tab. By pressing that auto completion, you will never get errors like this function does not exist, right? So just use this cascade classifier and just give the path of your XML file. For example, har cascade frontal face alt1.xml. This thing, right? This thing. And you can call it as a detector, because actually this will detect your images on the this will detect the faces on the image, right? So I'll call it as a detector. So now there will be something in detector, right? So it is a cascade classifier object. Now what you can do, this detector this detector has a function called detect multiscale, and you can pass your image. Now what it will do, it will try to find all the faces on this image. For example, there can be like one face here, one face here, one face here, one face here, and it will give the coordinates of the rectangle so that you can plot the rectangle. So now right now you will see, if you do this, you get an array of what is the shape. So this array, so right now it is dumpy array, one column, one row, two row, three row, four row. So there are four rows and there are four columns, right? There are four rows and four columns. So let's call it as faces. Let's call it as faces, right? This thing, faces. Now faces has how many faces? Four faces. This is face number one. This is face number one. This is face number two. Each row represent face, right? Each row represent face number one, face number two, face number three. So if you take faces of 0, it means you are getting the first face. You're getting the first face. And these things are called your coordinates. So the first coordinate is the x coordinate of that rectangle. This is your y coordinate of that rectangle. This is the width of the rectangle, and this is the height of the rectangle. So basically I can plot a rectangle like this, right? So this rectangle will have some xy coordinate, height and width, right? So these are the coordinate of that rectangle. So now what we can do, we can take x, y, w, and h, all these four coordinate in variables like x, y, w, h. Abhishek, C should be capital. Cascade classifier of C should be capital. If you write CV dot cascade classifier, I will get this thing. There's no attribute cascade classifier. But if I write C capital and I use cascade classifier, you will get this object, right? Now what I can do, I can plot a rectangle like this. PLT dot CV2 dot rectangle. This is a function CV2 dot rectangle. It accepts any image on which image I want to plot the rectangle. So on this image, what should be the point 1? It should be x dot y. What should be the point 2? It should be x plus w, comma y plus h. So basically, if I have the rectangle like this, I have xy coordinate here. So what would be this coordinate? If this is the width, if this is the height, this coordinate would be x plus w, y plus h, right? So I have to give these two coordinates, the coordinate number 1, coordinate number 2, right? And then I have to plot the color. So color, maybe I can give red color. Then thickness may be 2, and yeah, that's it. Okay, it required maybe a color like this, 255, 255, 255, the whole white color, and it gives the modified image. So let's say modified image is equal to this. And now if you plot plt.im show modified image, you will see it has plotted a rectangle like this. So how did you download that file? So file can be downloaded this way. So just go to download and direct download. Right? So now you can see it has plotted one rectangle, but there were 4 faces we already know. So what we can do, we can take iteration, we can do loop, right? So something like this. For one face in multiple faces, because this faces has had 4 faces, I can take x, y, w and h from the face, and then I can plot a rectangle like this, right? So let's remove everything. So because we do not want all these things now. So let's try to do it from the very beginning. Let's do kernel, restart and clear output, and let's do from very beginning. So let's import all the libraries, right? Let's read any image. You can give your image or maybe any photo. This has a 563 and 1000 rows and columns, and this is the whole image, right? Now let's read the har cascade file that we have already downloaded, right? That is we have already downloaded. So let's call it using the cascade classifier object. and we got the detector. Now this detector has a very interesting property called detect multi-scale. Oh no, this is a function, detect multi-scale, and you can pass image. Whatever the image you had, you can pass this image, right? And you will get lot of faces, lot of like you can get like 5 faces, 10 faces, depending on the number of faces in the image. So I'm keeping it to the faces variable. This would be a list, or you can say the array, something like this. Now these are 4 faces because each row represent one face. So I can iterate over each row. So I'm saying for face in faces, and each face has 4 properties: w, sorry, x, y, w, and h. Right? So I'm keeping x, y, w, and h, and I'm creating a rectangle on modified image. So cv2.rectangle, which image you want to plot? Image, which is the original image, right? And let's keep it on image already, right? Then the first coordinate of rectangle is the top left coordinate. It is x and y. The bottom right coordinate is x plus w and y plus h. This is the color of the rectangle. Which color do you want? So 2 to 5, 2 to 5, 2 to 5 means the whole, you can say white color, right? If you want some other color, you can create different colors. And this 2 means the width of that rectangle. You can have very thin rectangle, you can have thick rectangle. So let's keep 3. And let's execute this now. So we have executed. Now let's do plt dot and image. Now you can see it has plotted 1, 2, 3, 4 different faces that are front facing. But this lady was not, we can say that this lady was not front facing. That's why this model couldn't capture her face. One reason can be this thing, right? Because she was not front facing. Exactly, she was not front facing. But this way, like, we can plot different number of faces, right? So I hope this is clear how we can do face detection on any image. It can detect any number of faces. For example, if you take a different photo, let's take a different photo, right? Let's take group photo. You just need to replace your group photo with the photo that we have saved there, right? Let's keep this photo now. I'm keeping group photo 1 dot. So I have saved another photo, group photo 1, and let's call it group photo 1. This is our photo, right? Group photo. We have to detect faces. So again, let's load detector, and let's call this detect multiscale.img. So it is giving some error on this image. Okay, so let's try to do clear output restart. So maybe this could be the issue with image as well, because this was PNG image, whereas our model was only for JPG types of image, right? So maybe we can take some other images as well. So let's try to take this image, if this works. Let's try to take this photo, group photo 1.jpg, and let's try to run this. Now you can see now you got lot of faces, right? So obviously we cannot get 100% accuracy. So therefore, like, it can happen that it might happen that some of the faces are skipped. So now in this case we got lot of faces. You can check here, like 1, 2, 3, 4, a lot of faces. So now let's execute it and let's plot it. So you can see most of the faces are detected, right? So it just skipped this photo, this face, right? And most of the faces are already detected. So this was like the basics of image detection, and obviously there are like advanced techniques using CNN and other things that we can use to detect faces. So I'll just push the code to the GitHub. So you can see the code, right? We have already pushed the face detection OpenCV part. So for detecting side faces, we do not have any specific. We have to write any our algorithm to detect the side faces, right? You do not have a thing called har cascade in side faces. So there are multiple side faces. So there are multiple har cascade files. So for example, har cascade classifier OpenCV GitHub. If you write this, so you will see there are a lot of har cascade files. You just have to change this XML file and you just have to change this XML file and you will be able to detect like a lot of things. For example, this is full body.xml. This file is full body.xml. So what this file is capable of is do the same thing as we have seen here. This file can detect the full body, right? Similarly, this file can detect your smile. So when you smile, it detects or plot the rectangle, otherwise it will not, right? So same way we have eyes, we have we have eye, left eye, right eye. So we have different types of things, right? So I hope you are able to get how cascade classifier works, and hopefully you will be able to do a lot of different things. For example, if you want to do car detection, hopefully you will be able to do. And but for that you need to create your own cascade classifier. You need to create your own har cascade XML file, right? That would be a bit tricky, but you will be able to do like if you do some search on how to create our own cascade classifiers. So I hope you will be able to perform this task. You will be able to do face detection on the images, right? Just one more thing, if I can do. Uh, okay, yeah. So that's it. Like I hope like you will be able to do face detection on your custom photos, right? So any doubt so far? Like if you are not able to understand anything, or maybe if you want to discuss some other things as well. So those who are still watching, so I'll tell you, you will get the certificate right in maybe next 2 days. So just go to this link cb.lk/certi. So note this link cb.lk/certi. Now the thing is, when you go to this link, so let's go to this link cb.lk/certi, right? When you go to this link, it will ask you to log in into the coding blocks account. For example, I'll do it in, let me do it in a incognito mode. So cb.lk/certi. So if you are not logged in into the coding block account, so it will say to log in to continue, right? So you have to log in to continue. So maybe like you can directly log in with Google or Facebook or GitHub. Like how It's always like you can directly log in with Google, and once you log in, you will see this form, certificate of online workshop. So you just have to fill this form, and in the next 2 to 3 days, you'll be able to get the certificate in your mail. So you'll get the certificate in your mail, right? And just choose the data science. So the link is cb.lk/certi, CERTI. How to log in? You can just log in with Google. Where to find the variety of data science problem to solve? Kaggle is a very good platform. So you can try kaggle.com. Some basics challenges are house price prediction and Titanic dataset. So these two are two basic problems. So video capture. So what we can do is we can also use our webcam to capture the stream, or we can say basically images, because video is also images, right? So if you have heard about FPS, FPS is frame per second. So video is also made up of images or frames. For example, 24 FPS, it means 24 frame per second. So when you capture your video from the webcam, it actually is a video, but we have in 1 second 24 images. So what you can do, you can iterate over all your videos, like you take a video, right, and you iterate over the whole video, and in each frame you pass the frame to this part, right? Detect multi-scale, and each image will be different, each frame will be different, right? So detect multi-scale image, each image will be different here. Now if each image will be different, it will be able to detect different faces. And now the same way you can plot different faces. So there is one idea or concept of face detection on video camera as well. So you can also use webcam to detect your face on the real time, but I won't be able to do that because right now YouTube is accessing my video cam. So it would be difficult to access like same webcam in the two ways. Also, I want to know about Git repo. So the GitHub repo is cb.lk/face work for today's example. So thank you guys for attending the session and being till the end of the session. So
Hi guys. So I was also watching the session. So there is small assignment. If you guys want to try, we can share it with you. So it's an assignment on Coding Blocks Online, where you would learn to build a Snapchat filters using all the techniques you have learned in this session only. Okay. So what we can do, we can email you a link, and there you can submit this assignment on building a Snapchat filter. Okay. So we will give you the dataset, we will give you the file. You just need to use the code that is taught in today's workshop to create a very cool Snapchat filter. Okay. So yeah. Okay, so there is a doubt by Karthik. Should we learn machine learning directly using sklearn or full implementation of all algorithms? Okay, so if you want to become a data scientist and you want to go deep into the ML field, then you should learn all algorithms. But if you are a mobile developer or a web developer, you just want to make some apps, then a basic overview is also good. Okay, so yeah. So I hope Karthik, your doubt is clear. Okay. So a lot of more workshops are lined up. Okay. Any workshop on deep learning. So I think Mohit is also taking some workshops on deep learning. Also, I took one workshop on deep learning. I will show you. I took a webinar on COVID detection. So that webinar is also there in the Coding Blocks YouTube channel. It uses a deep learning technique called convolutional neural networks. So we have done 2 workshops on that. So you can check out my webinar on convolutional neural networks and COVID detection, how to detect COVID using X-rays. Okay, so that's also there on the Coding Blocks YouTube channel. And this workshop was exclusively for you guys who had registered. So you can access this through the link that you have got on the mail if you want to revise it later on. Okay. So yes, you can use Raspberry Pi. Yes. Okay. So mentor name is Mohit. Mohit bhaiya took your workshop, so you should give his name for the workshop. Okay. All right, guys, stay tuned, and we will be keep on doing some sessions every month. Okay. How to log in? Okay, so you just click login with Facebook or login with any other social account. Okay, so you can create a new account. It's totally free. You do not need to. Right. So Rachit, if you have any doubts, you can just mail the notebook to Mohit and me. We will try to help you out. Okay. All right. Bye bye, guys. Bye, Simran. I saw your
Bye.
attendance from the beginning, entire session. A lot of you have like spent over 2 hours in today's session. That's really great. And yes, we hope the session was very helpful for the beginners as well. Okay. And if you have any interesting ideas, any interesting projects you would like to work upon, you can share in comments. You can drop us an email. So we'll try to get back to you. Okay. चलो bye bye guys, good night, and COVID अभी चल रहा है तो stay home, take care. That's all for today.